Hello and welcome to our one of our first videos on a lab that we're looking at doing in our first lab block. It's called the determination of an iron sample via permanganate. Now for this lab, our main objective here for this lab, and I'll just kind of highlight a few things here. I'm not going to go through all the procedure here. That's for you to kind of look over. But one of our main objectives for this lab, okay, is twofold. One is just straight up, stoichiometry. We are going to be using stoichiometry in lab. That's what's our class we've been talking about. So stoichiometry is probably our #1 thing that we're going to want to use. Here also, a titration is a main laboratory tool we'll be using. In this lab uses lots of titrations, and we'll review how to do that as well. And finally, one of the main concepts here is percent by mass. Now we're actually going to use percent by mass to determine an unknown compound. So percent by mass, as you hopefully know, fairly simple mathematics, is the mass of the iron, actual iron in your sample, divided by the total mass. Okay, rather than we just times 100 to get it into percentage. Now, of this particular option, the mathematics is actually fairly straightforward. If I wanted to do this calculation, all I would do is take, let's say I'm going to use this pen here. This is relatively new for me, but this calculation here, this one simply comes, well, through some stoichiometry, but the total mass of the sample right here is very easy to get, because when you weigh out your original sample, the total mass, you will have that value. So the very first thing you'll do, this is from the mass of the actual sample. So you have that, if I can spell it right. All right, close enough. Sample, PL. The mass of your sample, you'll have 3 of them. Obviously you want to run several trials at once, but you'll have 3 of those right off the bat. So now our goal here is, how do we actually get, if I have a weigh boat, and you'll be using these little plastic weigh boats, and I have a certain amount of my little unknown iron compound in here, how do I figure out how much actual iron is in there? Okay. Well, on top here, this is one of our main ideas we use in honors chemistry, is in order to determine an unknown, we must have a known to compare it to it, and that's going to play true in this lab, very well. So in this case, let's turn back to our lab for a minute, or our first part of our lab. I'm going to flip thing, and you'll see some lab notes that you'd want to read through, and there's that little quote that I was discussing, and then it starts talking about the percent mass here, and you'd want to make sure you read all this, and it's saying the first step of our lab was called a standardization. Okay, so let's take a brief look and see what we're going to actually do here. Our goal is to test our iron. Okay, so what we're going to use is, I'm going to switch to another slide. Reaction number 2 is we're going to use this reaction right here, which is going to test iron via permanganate. So in this particular reaction, now this is our second reaction as you read through. This is our known, and this is our unknown. And whenever we are doing a titration, very often we make up a little chart like this for our titration, and we'll have our known on one side and we'll have our unknown on the other. This is something that people use and like. We have our molarity, we have our moles, and we have our volume, or in this case it'd be liters. Now in this case, when we reach our equivalency point, these two things will be equal. So pretty straightforward. We're going to add given the concentration of the permanganate, we would be able to, at a 1:5 ratio, be able to determine the iron. All right, so in that case, this is this guy here, given this concentration here, given the amount of volume here. Now remember, this whole thing here is in the burette. Okay, this would be the concentration of stuff in the burette. This is the volume. So out of this thing here, every single titration, we would have a start value, an end value, D there, and we just simply record it, and that would be our change in volume. That will be usually in milliliters, converted over to liters. Solve for the moles at in this case, a 1:5 ratio, so this is going to get multiplied times 5 to get this. Okay, we now would have our moles of our iron. Okay, now from here we could, if it was in solution, we could do a volume and a molarity, but in reality our overall goal is to find mass. So at this point we will take our moles and we'll jump right to mass, and we'll be able to just multiply this guy by the molar mass of iron. As I glance over the periodic table, molar mass of iron is 55. So we take this guy here and multiply it times 55. Now, I'm going to back up 1 second here, and hopefully this made sense, but the question is, what is the concentration of my permanganate? That is not given in your lab. So the first step is to determine the concentration of the permanganate. Determine what value do I put in right here. Okay. Now there is a video on how to set up your burettes and how to use a burette. You'd want to watch that if you don't remember from honors chemistry. Now let's back up a slide here. Let's talk about my standardization. Okay. Now, a standardization simply means that we are going to, and this thing's going to jump right here, to verify a concentration, okay, or determine a concentration. Now, it's a unique situation in the sense that we're going to determine a concentration so that we can use that substance to find something else, And one might think, well, why in the world would we ever want to do that? That just seems like more work. But it turns out to be a pretty common practice in chemistry, because when we titrate against this permanganate, the permanganate could possibly be absorbing water, which is called hydroscopic. Okay, so a lot of the stuff we use could be hydroscopic, so that means if I were to use a certain portion of it, maybe the concentration isn't what I thought it was. So what we do is we titrate our compound we want to use against a standard. In this case, we're using oxalate. The actual chemical is sodium oxalate. Okay, sodium oxalate would then be dried, and it'd be a known dry standard that doesn't really absorb a lot of moisture. So we know that when we're titrating against this thing, we are truly getting an accurate value. So when you do a standardization, you really want to make sure you're getting a true standard concentration. Now, this is really no different than the last one. Okay, so our goal now is to use our same idea. In order to determine a known, we must have an unknown to compare it to.